Hi, welcome to my video on the diagonals of a rectangle. A diagonal of a rectangle is a segment drawn from one vertex to another, not being a side. So if I draw a diagonal from D, it will go to B. I'm not allowed to do this because that's a side, or there. Or if I draw a diagonal from A to C, down through here. So a rectangle has two diagonals, and as it happens, those two diagonals are equal. So the diagonals are AC and BD. It's the two diagonals in the rectangle. A rectangle PQR has PS as 6 centimeters and SR as 8 centimeters. Find the length of the diagonal. Well, we draw a rectangle which has opposite sides equal, and has 4 right angles. So we go P, Q, R, S is a rectangle, has 4 right angles. And it says PS is 6 centimeters, SR is 8 centimeters, and we want to find the length of his diagonal. So opposite sides are equal. So if PS is 6, QR is 6, if SR is 8, PQ is 8, and I can draw SQ as a diagonal or PR as a diagonal. It makes no difference, so let's draw this one. And when I draw the diagonal, I have a right triangle, and to find the length of the diagonal, I'm going to call the diagonal D, D for diagonal. Because we have a right triangle, we use the Pythagorean property. C squared is A squared plus B squared. C is the hypotenuse opposite the right angle. So C opposite the right angle is D. So C is the D. The A and the B could be 8 and 6 in any order. As long as you, in the Pythagorean property, you fill in the hypotenuse first, then you should not go wrong. And 8 squared is 64, so 8 times 8. 6 squared is 6 times 6 is 36. And D squared, as you add that up, 64, 36 is 100. That means that D is equal to the square root of 100. So D is equal to 10. So the length of the diagonal is 10. 10, and the units are centimeters. So the diagonal is 10 centimeters. And also, if you did PR, you also get 10 because the two of them are equal. Practice means pause the video and work out this problem I have here. It says that X, Y, W, V is a rectangle. Okay, well, let's draw the rectangle, keep everything okay. A rectangle has 4 right angles, and it has opposite sides equal. So it has that side equal to that one, and that could be the length if you want, and this is the width. It says that XW, let's label it X, Y, W, V. Notice I go from X to Y to W to V. I have to go in this order. XW is 13, so there's XW 13 right there. XV is 5, XV is 5, so that's a Y, and that's a V, so that's a 5. And it says find his area. So I have a rectangle drawn, and I have a diagonal 13, a side of 5. In order to get the area, I need the length and the width, but I don't have the length. Again, I have a right triangle, and I have the Pythagorean property that I keep emphasizing and stressing because it's very important. C is opposite the right angle, so C is 13. A is 5, and we could call this, if that's the width, we can call that L for the length if we want. 13 squared is 13 times 13 is 169. 5 squared is 25 because it's 5 times 5. And so that means L is equal to 169 minus 25. L equals 144. Notice I left the L on the right side, and I moved my 25 over. Because I moved my 25, I made it negative. And so that's L squared, L squared, L squared, L squared. So L is the square root of 144. So L is equal to 12. So that means I have a width of 5 and I have a length of 12 that I just worked out. And the units are in feet. So the area is length times width. So that's 12 times 5 makes 60. And again, the units are feet. So feet times feet gives you square feet. So the area of the rectangle is 60 square feet. Let's continue with the diagonal of a rectangle. This is an interesting one. A spiral staircase. Well, if you take this rectangle I have drawn here, A, B, C, and we can make this a D or leave it out if you want. But what I'm emphasizing is that I have the top, the length in pink, and I have the height in black, and I have the diagonal AC. If you take this rectangle and make a cylinder out of it, it will look like this. So to do that, I've drawn another one, which is this one, just like the one I have above here and labeled. So if I take the rectangle and roll it over and that join it together to form a cylinder, watch. So I could go backwards like this if I do, okay. Notice the height is falling on the black. Notice the pink that rolls around is the circumference of the circle. And behold, the diagonal, that's AC here, becomes, as you can see, becomes the spiral staircase of the cylinder. Very interesting. So this diagonal AC moves from A up the spiral staircase, and there it is there. Notice. And when we do that, if we make this a 6 and we make this an 8, as we worked out before, C squared is A squared plus B squared, and my diagonal D squared is 6 squared plus 8 squared. D squared is 36. 8 squared is 64. D squared is 100. D is the square root of 100. And D equals 10. So this diagonal is 10. That means that this staircase here is 10 in length, which is the diagonal of this. And that means that if that's an 8 and that's an 8, that means the circumference is 8 meters, if the units are meters. So that's an 8 meters going around there, because that's the distance, the pink distance there. So that means C equals 2 pi r. 8 equals 2 times 3.14 times r. 8 equals 6.28. And that means we divide by 6.28. So that means that r equals 1.27. And we want meters or centimeters. Okay. If we want meters up here, meters. So that means the radius of this cylinder that's formed by rolling, making this rectangle into a cylinder, that radius is 1.27 centimeters. Let's work backwards from that now, working on this idea. So we have a cylinder, notice. We have a spiral staircase moving from F up to T, up to V. There's the spiral staircase moving around the cylinder, like the one I just showed you, like this one, when you rotate it. There's the spiral staircase. So that's that one. But I want, if given this cylinder, given this spiral staircase, this cylinder has a radius of 10 and it has a height of 20. Again, the units are in meters. Unit is meters. I want to find the length of the staircase. To get the length of the staircase, we have to remember that if we undo the cylinder, if we cut the cylinder down to its height, we would have 20 is its height, and the radius, which is 10, the diagonal would be acting. There's the diagonal. The diagonal would be the staircase. So it's a little bit different. Have to think about it. We have a right angle. So that means that this right here is the circumference. So that circumference is right there when you unfold it. And the circumference is 2 pi r. So the circumference is 2 times 3.14 times the radius of 10. And so that gives me 62.8 meters. 2 times 3.14 times 10 is 62.4. So that means that that's circumference is 62.8 meters. The height is 20 meters. That means to get the length, get the diagonal of this right triangle, which is the length of the staircase, I have to use the Pythagorean property. And the diagonal or the staircase, we'll call it D. 20 is the one side. 6.28 is the other side. Remember, C squared equals A squared B squared. C is always the side opposite the right angle, the longest side in your right triangle. C squared, 20 squared is 400. 6.28 squared is 3,043.84 if you use your calculator. And if you add 400 onto that, you get 4343.84. And that means that D is the square root of that, 4343.84. And so that means D is 65.907, etc. So that means we want to round it to, it says round the length of the staircase to the nearest meter. So the nearest meter is, that's a 9, so we make that a zero, all zeros. We add, because that's a 5 or greater, we add 1. So the length of the staircase is 66 meters. And just a different problem, thinking the diagonal of a rectangle, when you form it into a cylinder, becomes the length of the staircase. And if you like my video on the diagonal of a rectangle, then click on the like button, the subscribe button, and the notification bell if you're a subscriber. Write a comment on my video if you wish. And also visit my math website, www.mathfullyexplained, where you'll find information on me, my teaching style in my videos that I'm going to use, and all the content I have on my YouTube channel, plus all the content that's going to be there in the near future. Thank you very much. Bye-bye.